Hi everyone, it's Ken here. The emphasis in this video series, besides building a clock, is to compare manual machining with CNC machining. So in this video, we're going to dive into using CNC on the lathe. The clock has numerous parts that need to be made on the lathe, and I'm going to choose a couple of different ones just to show you some of the different methods and techniques for using CNC on the lathe. The collet is used to hold the gears on the pivots. I'll show you that. This is a collet. It will screw onto this gear, through these three screw holes. Now I could go into the cam portion of Fusion 360 and set up a cam operation to make this. Problem is you can only make half of it, and then you'd have to turn the part around to make the other half. So what I've done instead is I've created a drawing which I can just print out and take down to the workshop. It shows us that this portion of the collet is 0.188 inches in diameter, and it's 1/4 of an inch in length, and that the entire part is 1/2 inch in diameter. It may not be obvious from the videos, but as you can see, I have a very small lathe, and with that comes numerous limitations. One of the problems is that because the spindle is not bored as it would be on a big boy lathe, I can't have my stock pass through the spindle and only expose the short piece that I want to work on. And you're never supposed to have the stock hang out from the spindle more than 3 times the diameter, which in this case would just be about 1.5 inches. So what I'm going to do is use my steady rest. As you can see here, I've recently modified it to add ball bearings to the fingers. It just makes it work better that way. And using the steady rest, I can expose just the piece of stock I want to work on so it's not deflected when I begin cutting it. As always, I face off the end of the stock, and then I use that position to tell the machine controller where Z0 is. And then I turn a diameter, measure it, and use that information to tell the machine controller where X is. Most machine controllers have some sort of a built-in mechanism for performing simple CNC-like operations. This one uses what they call wizards. And as you can see, they have wizards set up for OD turning and boring, tapers, arcs, grooves, all sorts of different things. But these are just your standard operations that everyone does on a lathe, whether it's CNC or whether it's manual. We need an OD turning operation. And this is very much like what we want to make here. So we fill in some parameters. They want to know the fillet radius, which would be if we wanted to leave a radius here. We don't. We want a sharp corner, so we set that to 0. X is going to start at 1/2 inch because it's a 1/2 inch piece of stock. And it's going to end at 0.188 because that's the diameter of this shoulder here. Z is going to start at 0, which is the end of the piece where we just faced it off. And we're going to come in 1/4 of an inch, which is 250. The clearance is just how far to retract the tool to bring it back for the next pass. And then you set up some feed rates for roughing, depth of cut, and a finish feed rate and a finish depth of cut. That's all you have to do. You post the code, and it generates it. This is all the G-code to do that operation. And this is the tool path. Back to the main screen. And now the G-code is loaded into Mach 3. It's ready to run. We can see the tool path here. All you have to do is turn on the spindle and hit cycle start. Now, of course, there's nothing preventing me from turning the cranks and doing this manually, but I find that turning the cranks just, makes me cranky. Now that one side of the collet is complete, I can part it off, leaving a little extra material for facing when we turn it around to machine the other side. Next, I'll move the steady rest back a bit so I can machine each of the other two collets. Then I'll place a collet in the chuck so we can machine the other side of these parts. I've carefully measured it so I know how much I have to face off to achieve the final length. The next step, of course, is to go back into the wizards, set up a new one for what the other side of the collet looks like, and then machine that. As you can see, one of the collets is made from steel, but they all work essentially the same way. The final step is to spot drill, drill, and then ream for the final diameter of the pivot rod. I took a cue from Chris at Clicksping and made a reamer using an actual piece of the pivot rod so that I get an exact size hole. The lathe work on the three collets is now complete, and in a subsequent video I'll move them over to the mill and drill and tap the three holes that are needed to mount the collets to the gears. The next part we're going to make is the pillar washer. It's a very simple part. You can see that this washer here is just a decorative feature for the screw as it goes through the frame and then holds onto the pillar. Well, first off, this is an incredibly easy part to machine manually, but this video is about CNC, so if we go into the cam, I've already set up the operation. It was trivial. But as you can see, it's going to run a tool path. You know, the tool is just going to cut this little chamfer. So let's go do that. The first thing I have to do is face off the part, and I'm doing this manually. Once I face off the part, I know that the tool is at the end of the part. It hasn't moved, and I know the end of the part is what we want to reference as 0, so I just click the 0 here, because that's where the tool is. The next thing we have to do is ensure that the part is round, and because we're making 6 of these from the same blank, I'm running the tool all the way long enough to do all 6. Now I can measure the part to see what the actual diameter is when it's been turned. Once we've used the tool to cut the diameter, and we just measured 0.497, so that's where the tool is right now. We know that because it just made a cut at 0.497. Now we can run the CNC code and cut that little chamfer. At this point, I went off camera and drilled the hole through the entire blank and did a little bit of sanding and polishing to get the part looking nice. And the final step is to part off the washer. A bigger CNC machine could do this automatically under program control, but on my machine I have to do this manually. I know a lot of you are thinking right now that this part just should have been made manually. And you're right. The reason I'm showing it being done by CNC is just to make the point that some parts are better made manually. The cutoff tool always leaves a lip around a hole. So what I do is I just take a chamfer bit, and with a few twists, that extra part just comes right off. One down, 5 to go. Now the last part we're going to make in this video is the pillar itself, which you've seen. That is the spacer and support that holds the front and rear frame together. The pillar has, a fairly interesting shape here that needs to be turned on the lathe. And it also has these bosses at the end, which are threaded for the screws that hold it to the frame. So I've set up two separate operations. One is just going to machine this protrusion here where the screw goes into. What's interesting is that the plans call for this to be back cut a bit and this to be tapered a little bit so that it fits neatly in the frame and flush against it. If we were doing this by hand, we would have to take care of all of that in separate operations. But using CNC, I've actually modeled those slight angles right into the part. So when the CNC operation runs, it will take care of all of that. We'll then flip the part around and run the same operation on this side. I begin by facing off the stock. Then I remove it from the chuck, measure it, and mark at the point where the final length will be. Next, I reverse it in the chuck and face it down to its final length. After setting up the X and Z starting points, it's time to run the CNC code. Then I center drill, drill, and tap the hole, and then check it for fit. When one side is complete, I reverse the stock in the chuck and then run the same operations on the other side. Once that's done, we're going to have to mount the part between centers. And now I've generated this tool path. So with one tool, we can just come in and make the entire profile. If we were doing this by hand, And if you've watched Chris on the Clicksping channel, what he had to do to make this by hand was he had to machine a special tool, a form tool, to cut this radius on both sides. And then he had to machine another form tool to cut this one. And he's got an entire separate video on just how to make a form tool. But if you're using CNC, it's just a matter of a couple of mouse clicks, and one tool will do the entire thing, and every pillar will come out identically. Let's go watch that happen. Now, since both ends are drilled and tapped, mounting it between centers is simply a matter of screwing it onto a piece of threaded rod, and then supporting the other end with the tailstock. You'll note here that I've switched to a center cutting or neutral cutting tool. Using that to find X, or the diameter, is the same as the left and right hand tools I was using before. However, locating Z, or the end of the part, becomes much more difficult because there's no reference point. So what I've done is I've measured the part, determined where the halfway point is, used some die chem and marked that point, and now I can visually align the tool with the exact center of the part. From the CAD drawings, I can easily tell where the center point of the part is, so I go back into the machine controller and just set it. Because although we've typically been setting the controller at 0, we can really set it any place we want. It just has to know where it is. Turning this profile manually would be a whole lot of work. And this is why I love CNC. The code begins by roughing out the shape of the pillar. And then at the end, it takes a finish pass, and the part is complete. Each of the 3 pillars that I make will be identical. The pillars and washers are now complete, except for sanding and polishing. And here they are temporarily installed in the frame. If you like this video, please let me know by clicking the like button. If you'd like to be notified when I post new videos, please click the subscribe. I enjoy your comments and try to answer as many of them as I can. If you're interested in my other projects, please visit my website, which you can find at www.zeman.com. I will see you all soon.